for number 1 in the warm-up, anytime you have a trig graph, does everybody agree with me that sine and cosine functions both are waves? Okay, so anytime I give you a graph with waves, couldn't you just pick a different part of the wave and write an equation for that part? So every trig function that looks like a wave, you can actually write as sine or cosine. On your homework last night, for most of the graphs, I only gave you one part. So you only had one option of an equation. Does that make sense? So on the test, I will more than likely give you one part. If I give you one like this that has multiple parts, then I'll accept multiple different answers as long as they are correct. So let me show you what I'm talking about. A lot of people in class were saying they would write this as sine. If it was me taking a test, I noticed that both ends are pointing up, which means it's even. So I would write it as cosine. This one is going to be a little easier to write as cosine because both ends are up, which means it's even. Okay?
Miss Poole,
Yes.
isn't the cosine function just negative sine?
No.
Okay.
Good question. No, we're going to get kind of into that today and talk about how they're all related, okay? All right, so if you look at this, the other thing I notice is that how many parts of the wave does this have? 2. How many parts of the wave do we need to write the equation? Just 1. So I used this piece right here. Could you have used this piece? Yeah, so we'll get different things and that's okay. Are you guys okay if I go off of the green though? Okay, so let's look at the green part. Everybody agrees that this is cosine because it's one full part of a wave. It goes down and back up and it's both ends are opening up, so it's even. It's got to be cosine, right? Okay.
Yeah.
So cosine, we know there's going to be something in parentheses, right? What's the very first thing that you probably should have noticed, though?
The period is shortened.
Okay, good, Kevin. That's not the first thing kids normally notice, but good. Yes, I do agree. The period is shorter. The midline. You should notice that these middle points are up at what? 1. What are they supposed to be at? 0. So what did we do to our graph? We moved it up 1. So there should be a +1 on the outside. Is everybody okay with that? Now, once you look at how we moved it up 1, you should also be able to see the what? Amplitude. So what's the amplitude? How many does it go up and down below the midline? 2. So we also vertically stretched it by 2. Are y'all okay with that? So now the only other things we have left to find are the phase shift and the period. Very good. So if you look at this, a cosine function, this very first point is supposed to be at 0, 1. Does everybody agree? So it's supposed to be here at 0. Where is it starting on this graph? Yeah, -pi/2. Supposed to be here on the y-axis. They're both supposed to start from the y-axis. This one is starting over here, which means I shifted it where? Left pi/2. How do you write that in the equation?
+pi/2.
Plus. Good. You should always write the opposite. So I'm going to make sure I left myself enough room. So this should be x plus pi/2 because it moved to left pi/2. And then I don't know if y'all were up here for this. They kept telling me in class that the period was pi/2, and I was fussing at them because it's not. If you go from the starting point all the way down and back up to where you started, what is the horizontal distance?
1 pi.
Yes, thank you, Kevin. It's pi, babies. If you put pi over 2, because this is pi over 2 to 0, so that distance is pi over 2. And then if you go from 0 to pi over 2 more, half a pi and a half a pi makes 1 pi. So your period should be 1 pi. Who does not understand that? Thank you. Because if y'all can't look at this graph and see how it goes half a pi and then half a pi more, we got a problem. Period is not pi over 2. It is half a pi plus half a pi, which makes a whole pi. If you couldn't see it from that piece, look at the second wave. It goes from pi over 2 to 3 pi over 2. If you subtract those to find the distance, that's 1 pi. Is everybody okay with the period being 1 pi?
Oh, wait, I have a different question about the phase shift.
Okay, hang on. Let me answer their period question. Like, let me make sure they're okay with the period, and then I'll answer your question. Okay, Kev?
Okay.
Okay, so the period is 1 pi. What is the period supposed to be for a parent sine or cosine function? 2 pi. Some of y'all are not understanding why it's 2 pi, even though we spent like 5 minutes on it yesterday. I need you to understand this comes from the unit circle. How long does it take the sine and cosine values to start repeating on the unit circle? 1 trip around, and then everything starts repeating, right? So what is 1 trip around the unit circle? What is that distance? What's that angle? 360 degrees or 2 pi, which is why the period is 2 pi. If it's supposed to be pi for this graph, how do we go from 2 pi to pi? Divide by 2, or it's just half? Does everybody agree? So what we're doing is we're horizontally compressing this by a half. We're taking that horizontal distance, the period, and pushing it in. So it's closer together. So if I compress it by a half, what should my equation say? Very good. That's just one of the options. You had a couple different other options for equations too. Am I gonna throw anybody off if I show you the other options? Are we sure? Kevin, I think you were gonna ask me about other options. So can I show you the second one? And then
Yeah.
if that wasn't your question, then I'll answer it. The amplitude is not gonna change. The period is not gonna change. The shift is not gonna change. But what if you used this purple piece right here? The midline is still 1. The amplitude is still 2. The period is still pi, because 1 pi over 2 to 3 pi over 2 goes 2 pi over 2 places, which is just pi. So this 2 is still going to be there too. What kind of shift would we have written if we used the purple piece? Remember, it's supposed to, good, it's supposed, not pi. It's supposed to start at 0. Good. Write pi over 2. So what would I write in here, Natalie? X minus pi over 2.
Miss Poole,
Yes.
I got a negative function, but I didn't get a phase shift.
I
got -2 cosine of 2x in parentheses plus.
What do we look at to find the amplitude?
A value.
Which is the what transformation?
The vertical.
Thank you, Kevin. Y'all gotta speak up. Only people in class getting extra credit are really Mary, Oswald, KJ, and Ross. I don't hear the rest of you. Speak up. Y'all love some extra credit. Vertical stretch. Don't call it the A value. I said what transformation? The vertical stretch will tell me the height. Okay? What about the period? What do I look at?
The horizontal vertical stretch.
Good. Horizontal stretch or compression, right? Either of these could be compressed. So let's talk about it really quick. Amplitude is the height, which means it is vertical, right? So I'm looking at that vertical stretch. The period is the horizontal, Ross was saying it's the horizontal distance for one wave. So that horizontal distance is going to be your horizontal stretch. How do I find the midline?
The y-intercept.
Transformations.
The y.
And
The,
the
like,
vertical
iron.
shift, which is what you were saying, Kevin. Vertical shift tells you the midline. And what tells me my phase shift?
The horizontal shift.
Very good. There we go. There's my extra credit, children. So this is my issue with Delta Math, and your homework for the next 2 days is not in Delta Math because they didn't even have these topics. Delta Math teaches everything by formulas. Y'all know I don't like that. How many of y'all actually remember formulas? Beautiful. No one tried to lie and say me. From what I can see, none of y'all have a photographic memory because y'all have to be flipping back in your notebook to see the unicircle. We're not doing formulas. You need to know I can look at these 4 transformations and find these things. Okay? All right, I'm pulling up the homework. This is going to be time for you to ask me any questions on the homework you had. I am going to re-emphasize, y'all, if you're virtual, try to get here on time so you don't come in the middle of stuff like that and get confused, because I'm sure you are. Sorry, Kelly, you'll test up. Let's see. I'll take this out of the recording. Sine and cosine functions homework. Okay, let me stop recording because I'm not posting this for people who didn't get on. If you can do sine and cosine, you can do cosecant and secant. It ain't bad. Okay? Rodney, are you dying? You look so bored. You're not bored? Did I blow your mind with showing you like all the different equations you could do? Okay, then don't pick the easiest one. Boom. I got you. All right, cosecant and secant functions. They come from sine and cosine functions because they are reciprocals. That is probably the most important thing you will learn today. Nothing else is really new. Not really anything new. So I want us to start off by just reviewing what the sine and cosine graphs and tables look like, and we're going to use that to discover what these two will look like. Does that sound good to everybody? And then we'll do a couple examples, and then we'll be on our merry way. I feel like I should be up here rhyming since I'm thing 1 today. I'm just going to start rapping the notes at y'all, Eric. What would you do if I did that? Not gonna play along. I feel like Drake would enjoy it. Drake would probably start putting me on his Snapchat. All right. Can we start with sine? Is that okay with everybody? Yes, ma'am. reciprocal. Reciprocal. Sorry, that is kind of small for you. I'll write bigger. All right, the sine function. What do we remember from yesterday? What does it start at? 0, 0. Very good. What else do we remember about it? It's odd. Good. What else do you remember about it?
Has a range of -1 to 1.
Good. What else do you remember? Extra credit for 3 of you so far. What else do we remember? There's one more thing. Then they all perked up. You say extra credit. Y'all are wild. The domain goes on forever, so it's -infinity to infinity, right? Okay. Let's review what our graph will look like and also what our table will look like. So I'm going to start off with the table, if that's okay with y'all. Remember, the x value is just the angle. And the y value is what we get when we do the sine of that angle. So y'all just told me we start off at 0, 0. Because the sign of 0 on the unit circle is 0. When we are at 0, remember that ordered pair is 1, 0. What's the next angle we use for graphing?
Over 2.
Good. Remember, you're just using your references, your barriers. So here, 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 and here. The 4 corners. What's the sine value at pi over 2? 1. Good. What's the sine value at pi? 0. What's the sine value at 3 pi over 2?
-1.
-1. I'm a little worried that not more of us are answering. I don't know if it's just because we're going fast, but you definitely should know those. You should really know the sine values at any point on the unit circle using your hand trick. All right, so does everybody agree if we graphed this? I know this is just review from yesterday, but I promise you're gonna want it up here. Everybody agree from yesterday, then that means it would just look 3 pi over 2 and 2 pi, and I'm gonna make this 1, or no, I'm not, I want it lower. 1 and -1. So it would look something like this. If you graphed those ordered pairs. Y'all remember that from yesterday, right? Okay,
Yes.
thank you, Natalie. All right. Cosecant is just the reciprocal. Does everybody agree? Guess we should be calling this X since I used X in the table, but it's all good. Is everybody ready? Don't focus so much on the graph. We talked about the graph yesterday. I need you to really pay attention to this part right here. The cosecant of X. If I take the cosecant of the angle 0, think about the ordered pair at the angle 0. Does everybody agree when the angle is 0 on the unit circle, the ordered pair is?
0, 0.
Oh, Lord Jesus. Y'all got to learn your unit circle or you are going to fail that exam and there's nothing I can do to help you. When
Oh,
the angle is 0, what's the ordered pair?
1, 0.
Thank you, Kendall. The sine is the what value?
Y.
The y. So that's how we got 0 right here. So are y'all ready to answer my question now? Okay. Cosecant is the reciprocal of sine. So if I flip 0, what happens? What do I get? Nope.
0.
Nope.
Undefined.
1 over
Oh,
0.
that's right. Don't second guess yourself. Don't do that. That was right. If you have 0, y'all, the radius of the unit circle is always what? 1. Remember, all of these values are always over 1. If you flip that, where's the 0 now? In the bottom, which means it's
undefined.
undefined. So y'all look, the cosecant of 0 is undefined. We learned this in units 1 and 3. If a function is undefined at a certain x value, what does that mean? Not a whole. That's at a certain point. If it's the entire x value, And it's undefined. What do we have there?
A hole.
Good, KJ. Good, Oswald. Not a hole. A hole is a point. If it's the entire x value, there's an asymptote there. Does everybody see why it is undefined at 0? I need you to understand that. If you be putting a point at 0 on your test, the whole thing is wrong. I'm not giving you any credit. It's undefined. The sign is 0. That's 0 over 1. You flip it, it's undefined. There should be an asymptote for the cosecant. Okay? All right. I'm hoping this next one will be a simpler answer. What's the reciprocal of 1? 1. Good. You shouldn't be second guessing yourself on that. So at the angle pi over 2, the cosecant is 1. All right, look at your sign at pi. It's 0. What's the reciprocal of 0? Undefined. We should all be saying that really loudly and confidently because y'all just told me you understood it. So at pi is undefined, which means we have a what at pi? An asymptote. Here she goes. Everybody okay with that? Yes, no? Okay. What's the reciprocal of -1? -1, good. So at 3 pi over 2, the cosecant is also at -1. What about my last one? At 2 pi, what is the cosecant going to be?
Undefined.
Good. There we go. Which means there's a what at 2 pi? There we go. This is the last part that's usually kind of difficult for y'all to see. So I want you to really pay attention and make sure you ask a question if you have it. Okay. Cosecant is the what of sign? Reciprocal. How do we find a reciprocal? Flip it, right? Listen to me very carefully. In between these asymptotes, does everybody agree this shape in between the asymptotes for sine is an upside down U? Flip it. There's that part for cosecant. It's the reciprocal. It literally is the flipped part of the graph. There's asymptotes there, so it can't go any farther, but it opens up. Now look at this part. In between these two asymptotes, this is a right side up U, correct? Flip it on that point they have in common. What should it look like now? Upside down. This is the graph of your cosecant function, the orange. Just the orange. So while y'all finish graphing that, or plotting that, I'm going to leave this up for you to copy. Maybe. Y'all can still see this, right? People at home?
Yes.
Okay. And I'm going to pull up Desmos while y'all are finishing that. You guys got it copied, right? So I just want to show you what it'll look like when you don't have the sine function there. Because these graphs won't have the sine part there. It won't have the wave. It'll just have the flipped pieces, okay? All right, people at home, can I change my screen?
Yes.
Okay.
Yes.
Woo, yes. Thank you, Kayla. She said, yes, ma'am. All right. Oh, wrong one. That's the graph of cosecant. I'll zoom it out a little bit so you can see. But it's just those up and down pieces. So does everybody see how these one piece goes up and one piece goes down? One piece goes up, one piece goes down. It is still odd. Does everybody understand that? One piece goes up, one piece goes down. It's odd still. But just to show you where it comes from, I'm going to now type in the sine of x. Do you guys see how it's just the flipped parts of that graph? Are we okay with that? It's kind of cool, right? When you graph them together. So let me show you what you're gonna have to do on homework, and then we'll talk about cosecant, okay? All right, let's flip to the ladybug again. These notes are short today. I only have one example planned. If y'all need more than one, I can do more than one. But I really don't know that y'all will need more.
It looks like a really fancy pattern you'd see on like an old lady's furniture.
Yep, it really does. I love these. I think they look really cool. They're also very useful in the real world, depending on what you want to do. All right, so what we're going to do in this example, I want you to find the period, the asymptotes from 0 to 2 pi. Let's see, period, asymptotes, the phase shift, and the amplitude. And so here's the equation. Sorry, y'all, I'm thinking. I'm not going to make it too hard at first. We'll do a pretty basic one.
It's cool.
Yeah.
When you're finding the asymptotes, you would move the phase shift with them, right?
Exactly. Perfect. So I didn't give us one to do it this time, but I'll actually do another one where we do that to make sure y'all are okay. Okay?
Okay.
Good. Very good, though. KJ, you need me to shift it up? Okay. All right. Are y'all about ready to talk about it? Are we still writing the problem, or are we trying it? I don't care if you're trying it. I would love that. I just wanted to make sure everybody was done writing so I could start talking. Mary, don't be scared of me. All right. First thing you should be able to see. Hello? Amplitude, good. Now, we do have to talk about this. The amplitude looks like it'll be what?
-2.
No, freeze. The negative just means it's flipped. That has nothing to do with the height. Don't worry about the negative. I don't care about the negative. I should have just given y'all positive too. I knew somebody would say that. Listen to me very carefully though. Look at this graph up here. Do these orange pieces have a height? Why not? They go up and down forever. So is there an amplitude? Smart children. Cosecant and secant go up and down forever because they're the flips. So there's no height. It goes on forever. Did everybody understand that? If I pull up Desmos again, those little arches go up and down forever. There's no height. So if you see somebody ask for amplitude on these, you're going to write that there is no amplitude.
Does the amplitude tell you where the dots will be though?
What do you mean by dots?
Like
Like
on that graph?
The vertices.
Yeah.
Yes, so that's what I was about to write. There's no amplitude, but everybody look, if the amplitude of sine was 2, because if this was a sine function, that would mean the height was 2, right? Is everybody looking? I feel like a lot of y'all aren't paying attention today, or you're just not participating, so I feel like I've been talking to myself. This 2 tells you that those vertices are 2 away from the midline. So what you can say is that the distance from the vertex, I'm going to say vertices because there should be more than one. Distance from vertices to midline is 2. Very good, Maddox, extra credit. Does anybody need to see that in Desmos graph? Would anybody like to see it? Okay. All right, so check it out. Let's graph it in Desmos. Y equals -2 cosecant of 1/2 x. Okay, this would be the graph. Look at that vertex. It's at -pi2. So that means it's 2 away from the midline. Does that make sense? Same thing with this vertex. So if they ask you for an amplitude, there isn't one because these green pieces go up forever. Look how long and skinny they start to get. They go on forever. There's no height. But what that does tell you is that they're 2 away from the midline. That 2 basically represents the amplitude. I can't spell. Of sine. And I have to put 1/2 to make it match. There you go. See? No. That's the 2 in the beginning. That's the amplitude. Good. That's not a dumb question. All right. So let's look back at our notes. We just found the amplitude. There isn't one, but I think your homework says something about finding the distance. So that's what that number will tell you. Okay? The period. You find it the exact same way. So the period of the cosecant function is just how long it takes, so everybody look, how long it takes for there to be an upward arch and a downward arch. So how long does it take? 2 pi. And then the next one would be a up and down and up and down. It's odd, so it's going to keep alternating, okay? So the period is the exact same as sine, because just flipping the function doesn't change the period. So the period is supposed to be what? 2 what? Say it with confidence. Y'all's mumbling is killing me today. Thank you. 2 pi. What did we do horizontally to this graph? Stretched it by, look at y'all smart children. It does the opposite, right? If we stretch it by 2, that means I'm multiplying it by 2. So what is the period of this one? Good
4
job.
pi.
Very good. Was there a phase shift? Is there any horizontal shift? There's no
No.
vertical shift either. No, so you can just write no phase shift. I put PS. You are allowed to abbreviate. And what's the last thing they ask for? Asymptotes. So this is the part that you may have to think about. Now, I will show you in Desmos how you can check yourself, but Desmos, remember, does not give you asymptotes, correct? Y'all remember that from last unit? Or not last, 2 units ago. Wow, we're going so fast in here. Okay, asymptotes. If we didn't shift it at all, are the asymptotes going to move? Nope. So where are they at? 0, pi, and very good. So for your asymptotes, you would say x equals 0, pi, and 2 pi. You can write them separate if you want. X equals 0, x equals pi, x equals 2 pi. Or you can do this. I'm not too picky about that. But you should know you'll have asymptotes in those 3 places. Even if the period moves, that doesn't matter. That just means they'll be more spread out. The asymptotes will move if it's shifted. Does that make sense? Okay.
So if there's no phase shift, it's the same as like the parent.
No phase shift, the asymptotes will be the same. So do you want me to show you on Desmos? Okay, let's go look at it. I believe I left those up there, so that's no trouble at all. All right, so let's move the stroker. So you're gonna have the one at 0, you're gonna have the one at pi, and you're still gonna have the one at 2 pi. Asymptotes do not move unless there is a shift. No, you don't. You don't want to ask? Okay, that's fine. Everybody's okay? Should we do another one where there's a shift this time so you can see how the asymptotes move? And then I'll show you what secant looks like, okay? KJ, you okay? It's okay. You can ask a question. I don't want y'all to be scared to ask a question. Okay, that's fine. All right. Uh-huh. Very good question. Let's look at another one. Huh?
Because like it'd just be 2 pi, so it would repeat twice.
Oh no, no. I think you're actually right. I think I just did that wrong. Let me go look at the graph again. You are right, Mary. Extra credit and good job, Brody. Oh my God, I was looking at the wrong flipping example. I'm gonna. No. You're right, KJ. This should make more sense now. Very good job. Extra credit. I'm so mad at myself. I was looking at the wrong example. I was like, what are y'all talking about? All right. If the period is stretched, the asymptotes will stretch. Everything will stretch. That does make way more sense. Mary, great job. I'm so proud of you right now. Is everybody okay with that? 0, 2 pi, and 4 pi, which makes way more sense because the period is to 4 pi. I'm not gonna lie, I was only halfway listening to you because I didn't take my ADHD medicine this morning. So I was like, what's this girl talking about? I'm so proud of you. That's why you got to be persistent and speak up and be confident. Very good. Good job, Mary. Can we do another one now? Does that make more sense? KJ's like, Lord, Miss Poole, you crazy. All right, let's do another one. Let's do f of x equals -1/2 cosecant, and then I will show you where secant comes from. Did I just do a half? Let's do 2. Oh, I'm not gonna put a period with this one because that's gonna be hard. We'll just do a shift if that's okay with everybody. All right. And then I will quickly show y'all where secant comes from. And we may have time for a secant example, we may not, but you do them the same way. So it shouldn't matter. Only thing that'll change is where our asymptotes are, okay? All right, for this one, what is the amplitude?
There is none.
There is none, but what does this 1/2 tell us?
The distance between the midline and the points are 1/2.
Very good. The distance between the vertices of my cosecant arches and the midline. Are y'all okay with that? But if it just says amplitude, you will put no amplitude because those arches go up and down forever. There is no height.
Ms. Poole,
Yes.
would there ever be an example that it has amplitude? Or?
Not for cosecant or secant because they're flipped and those arches go up and down forever. So these will always have no height.
Okay.
Good question. Y'all okay with that? All right, let's move on. What's the period? Good. Brody, why is it just 2 pi? You got it. Be confident. Somebody help him out. Why is it just 2 pi?
Because there's no horizontal stretch or compression.
Horizontal stretch or compression. So we're not making it wider or skinnier. It'll repeat every 2 pi. Are y'all okay with that? All right. Now, phase shift, because there is one. Somebody tell me what it is.
Right pi over 2.
Pi over 2.
Right pi over 2. So this is where the asymptotes may change also. They'll change if your period became wider or skinnier. We just did an example like that. So to get these, if you're kind of confused, what Mary did, I should say, because I won't even paying attention. She took where the asymptote should have been 0, pi, and 2 pi, and she just multiplied those by 2 as well. So that's how they're changed if there's a period change, okay? If there is a shift, all of my asymptotes will just shift right pi over 2. Does that make sense? So let's go look at our parent graph. The asymptote was supposed to be at 0, but I'm shifting it to the right. So what's it going to be at now?
Pi over 2.
Good, pi over 2. So we know there's an asymptote at x equals pi over 2. Now let's go look at the next one. Y'all okay? Do you need me to zoom out so you can see the graph too? Okay. So then the next one, if I shift it right pi over 2, it's supposed to be at pi. Shift it right pi over 2. Where's it going to be now? 3 pi over 2. And then look at what I told you in the first example. I only want the asymptotes from 0 to 2 pi, one normal period. So there isn't going to be another one for this one because the other one that was at 2 pi is now going to be past 2 pi. So we don't care about it. Does that make sense? Okay, I have roughly 5 minutes. Would y'all rather, I'm asking your opinion, would you rather me show you just the table for secant, show you what the graph looks like in Desmos and do an example? Or would you rather me do the table and graph by hand and no example? No example, you just want to see where it comes from?
Yes.
Okay, it's done the exact same way as these two. So let me show you the table. So we're going to recall, Mary, you're going to be my accountable person. Don't let me spend so much time on homework tomorrow. I wanted to make sure y'all understood sine and cosine, but for this stuff, people just going to have to come to office hours. Let me not use the wrong sheet. All right, so secant comes from cosine. So we're going to do x, which is just the angle. And then the y value is going to be the cosine of x. So we use the same angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi.
You put both x and cosine.
Right, because yesterday when I put a y over here, they got confused because I used a y. This is the input is the angle x. The output is the cosine of x. Are y'all following me? Kevin, are you okay?
Yeah.
It is the y value, but yesterday when I put that, people were like, but you put y. It's the output, input, output. But it's the cosine of x. I put that over here as well. Sine of x. Okay? What's the cosine of 0? There we go. What's the cosine of pi over 2? The cosine of pi. Cosine of 3 pi over 2. Cosine of 2 pi. Marvelous. So when you graph that, I am going to do it quickly and I'm not going to label. Not now anyways. It starts at 1. And then when we get here, -1, 1. It looks like this, right? So remember your cosine function, cosine of x is even. So both ending parts of the wave are pointing up. And then you have a piece that goes down and then it comes back up. Do y'all remember that from yesterday? You okay? Okay. Just want to make sure. All right. So when I am doing secant of x, I need you to remember it's just the reciprocal of cosine. What is the reciprocal of 1? 1. So at 0, 1, we're going to have a point for cosines, for secant still. Does that make sense? Let's see if we remember. What's the reciprocal of 0? Unsigned. Very good. So the only thing that changes is your asymptotes are in different spots. So there's an asymptote at pi over 2. And then there's going to be another one at 3 pi over 2 for cosecant. -1 flipped is still -1, so there's a point here. And 1 flipped is still 1, so there's a point here. So then just remember what I showed y'all last time. I know I'm talking while you're writing, but just watch. The pieces just flip. So this is a U in the middle pointing up. Where's it going to point for secant? Down. This is one little piece right here. Does everybody see it going to the up and right? So I'm going to make it go to the left. I'm just going to reflect it. And same thing here. This piece will just reflect. The examples are done the same way, except for what? The asymptotes are at pi over 2 and 3 pi over 2. Your homework should not take long. Virtual people stay on it.